Hello, hello, hello. We are live. Welcome to DevKami number 125. This is the last episode of Embedded Programming. So I'm Suming
I'm Tristan,
I'm Sean.
and
and
Sean.
Sean, our usual guys. Max Chiliong us. He actually have a sprint, so he'll be busy. I hope he'll get back to soon. Okay, what did I give me a moment? I'm so sorry I had echo in my system. So let's start with our meetups. Oh yeah, so what happened with you guys and how are you guys?
Oh, good. It's also busy. Lots of things
Yeah,
happening. It's end of the
yes,
quarter, so things are getting wrapped up. I don't know.
yes, it happens. So let's start with our events. So as it turns out, we have a busy week next week. Yep, we have DevOps Malaysia meetups. Then we have JavaScript meetup soon. I do not know where it is. Then we have Tech Up this weekend about human rights and technology. So, so I think this is the two big event happening this for the next week lah until the end of March. Interestingly, so unless something happens. So yeah, so let's talk about our news. Am I? Yep. Yeah. Oh, I opened the wrong tab. Let's talk the first one. Netflix had a new tool called Console Me. So, okay, so for the last week, I actually discovered AWS. And as it turns out, the permission to do things is ridiculous. It's even though it's called, I do it on a serverless level. And it turns out that to actually install, set up something, you need to set up the what's cloud. You need to set up the orchestration there, but those things require you to upload to S3, then you need the permission to S3, then from S3 you need permission to the databases, all the thing. So it turns out it's pretty complicated to me. So I discovered recently, I didn't use this yet, but ConsoleMe is actually from Netflix. It's a tool to actually help managing infrastructure permissions because as it turns out, as I discovered recently, all the IAM policies on AWS is pretty complicated. So what do you guys think?
Hmm? I haven't used it.
Okay, I think this will be useful because the AWS thing is confuse the hell out of me. But that's just so. The next one is GitHub remove POC code on for vulnerability. So critics have been a bit angry, and I agree with them because uh, it's
Well, you can
complicated. Go on.
you can argue both sides on this
Yeah,
because
correct.
yeah, if you put the proof of concept code, other people can easily more
Yes,
people can launch the attacks.
I
correct.
would I would say maybe a good way to do it is to suspend it until it's reasonably patched in. Like majority of the systems have been patched against the vulnerability, and then publish it like as a proof of concept to show other researchers what has been done and what could be done, right?
And
I
this
guess
actually
the
policy. Go on.
yeah, I guess the issue there is that it's been because Microsoft owns GitHub, so it feels like and it seems like Microsoft is exerting undue influence to silence like vulnerabilities against the mother company. So it
It
doesn't.
it, it,
It's
it
not
definitely
good.
feels like that.
Yeah,
Yeah.
Yeah, it definitely
it's
feels
not
like
very
that.
good optics. Although again, like you mentioned, right? In security, in terms of security, because Exchange is very widely deployed, you don't want like script kiddies to just figuring out, oh, this is a proof of concept, and then transforming it into like an attack that just brings down everything else. Like at least not to distribute it as early as now, but I think Microsoft should at least get the POC uh, published later on
Yeah.
for research purposes.
which is actually what a lot of the proper release policy actually. So let's move on. FreeBSD will get an in-kernel WireGuard. So WireGuard is actually a new protocol to actually do things like VPN and all that. But it's only recently that FreeBSD get implementation in kernel. And this is actually very interesting because turns out that pfSense and OpenSense, those things are using FreeBSD underneath. So this will actually improve performance when you want to implement the VPNs. So yeah, just something interesting. So some of you guys may not be using FreeBSD directly, but you use pfSense, that's FreeBSD. So something to think about. Anything to add? No, then I move on. Digital Ocean File IPO to actually
Make more money.
Yeah. Yes, and it's a popular services and all that. So yeah, nothing special here other than the fact that some consider them gutsy because I do not know what happened. So this considered gutsy because they actually will fight against the big boys like Amazon and all that. So yeah. And finally, white wine install available on Raspberry Pi. So this is actually a software for you to access your streaming services on Linux. I don't know how well it's supported on other platform, but let's say you had a media center running on Raspberry Pi. Now you have one extra option. So, and anything else that do I miss? If not, let's move on. So, today is actually the last episode of the embedded programming. So, for the past few episodes, we're talking about things from how do you start the idea, passive component sensors, and for many and one thing we discussed last week about sensors is those things are not smart, and we have a lot of things to do about communication. So today we're going to focus on the smart itself, meaning what do we do to actually connect our sensors into something that is useful. So the first question is, do you guys have any of these tools? Any of these development boards that you actually used before? They commonly used in your project?
Like Arduino, we have Arduinos.
Yeah. So we have these guys, of course. I like Arduinos. So what else do you have guys use? Because I use Arduinos. I have the M5 here.
I've used a very bad board from Intel before called the Galileo.
Oh yeah, that is
It's a horrible board though.
Yes. At that time I really tried to get into the Internet of Things area, but it didn't work out. It's just one of those things that Intel don't work. It don't work well for Intel. So at that time, I really tried to have it like a competitor for the Raspberry Pi, I believe. So that didn't work out. So that works. And it used to be in universities, students have to use the PIC because they get discounts from universities. So when I was in university, that is like almost 10 plus years back, they're still on PIC. It's actually very fascinating. That's before Raspberry Pi. So what else do you use? Also, before we go on with boards, we also have access to languages nowadays. So it used to be doing this is mostly on C, but if you're on PIC, you're also on BASIC, I believe. Am I wrong? Or is
You can also usually it's done in assembly with PIC.
Yeah, it's assembly, right? It's on assembly. Nowadays we have even the Arduino which is written in C++ is high level actually. We don't have to know things about pointers and whatnot. So yeah. So anything do you actually use? Okay, how do you choose actually? That's the first one. How do you choose something that you want to? Let's say you want to build a project, you need some smarts. How do you choose one of these dev boards? What's the consideration?
Well, at least for the Arduino, I think what they did well is that if you need something, you just get one, and then it's general purpose. Everything is through software. You have your SPI, you have your I2C, you have your UART, everything is there. And then that's
Yeah.
why it's very popular, because it just can do a lot of, like 90% of the small hobbyist projects can be done with that. So that solves the question easily. And many
Yeah.
hobbyists will not go beyond the capabilities. Maybe you'll need Bluetooth and you'll need Wi-Fi, and then you have your ESP32 there as an alternative. But otherwise, yeah, Arduino is just like the primary choice for many of the hobbyists.
Yes, but I do not
I
know. Yeah, go on. Go on
No,
first.
I think one of the main considerations, of course, will be price lah. If you're talking about buying
Yeah.
hardware, right? So Arduino
Yes.
as well. One of the reasons why it did very well is because it was quite affordable, right? 100 ring. Yeah, and then if you get those China clones, it's like even more affordable.
Yes.
So
Uh,
that's one of the big considerations. Besides the
Actually,
features and the capabilities.
yes, but it used to be Arduino is like 200, and that is acceptable because a professional grade development board is in the thousands. And nowadays, let's say Cytron actually have an official Arduino board. Those are like less than 100 ringgit, and it's actually one of those. It's pretty good actually, and it's pretty well supported internationally. So and nowadays Arduino is less of a hardware platform, so you don't get only this form factor anymore. It used to be you get these form factors, but nowadays Arduino is really just a software platform. So it's literally just this guy, and that's it. Uh, and of course the support libraries. So one thing I would suggest that if you want to do hardware development, start thinking about Arduinos because you got all sort of examples. This is what I like about Arduino. You got all the examples here. You can do it. What is this, sir? Oh, this is the ESP. This is the ESP32 example. So the only catch is the Arduino IDE is not really friendly for software developer like us. So for example, there's no option to integrate with Git easily. You don't have, it's still in C++, even though, so you need to understand a bit of it, but it's not too bad actually. It's not too bad.
And you can't really do real hardware debugging. Like you can't
correct.
step line by line through the,
Correct.
Yeah.
So one of pro grade hardware, you got actually have a thing called hardware. Is it still on screen?
Yes.
I'm so sorry. Okay, so you get hardware debugging. Not so much. You don't get a lot of those nowadays. You still get it in professional grade hardware, but you won't get it on the hobbyist hardware. So that's not something to think about. So as a result, most of us would just pick something out, then work with it lah. We just learn to work without it lah. So yeah, and nowadays all this hardware is like pretty cheap. So you got your Raspberry Pi Zero, 50 ringgit, 50 ringgit
20.
plus.
Yeah.
Yeah. So you got this nowadays. So what's the more interesting one have you guys worked on? Device support.
The Esprino boards are interesting. It's an NRF52, but custom made.
Yeah.
So they're it's very similar to the Adafruit boards, where there's also an ecosystem around it, but it's also quite easily programmable.
Yeah. So it used to be when we do hardware, we also consider about the ecosystem support on the shield itself. Do you still look into that nowadays?
Not the shields are not as interesting to me right now because they're usually more expensive, and
Yes.
I'm quite familiar with soldering, and with like small SMD components are just cheaper by like a dozen. So you don't need like any of those through holes. You can buy like a reel of like let's say 10 components. And it's much cheaper than like one or two of the through hole versions. And sometimes some components are just really only available as SMD. And if you need to find a shield with that component, it's just a lot more expensive because now you have a PCB, you have your everything else that makes it like easier to use, like capacitors and like all of these filtering stuff. So if you can just do it yourself, then it's just cheaper. So I don't do shields anymore.
Yeah. Now this is a bit rare because sometimes the manufacturer just use the connectors and just about it. So, for example, this guy, this is actually one of the M5 product, and even though they got all the GPIO on the bottom, can you see? Can you see? Oh, stupid.
It's not sharp enough.
So either way, you got the growth connector. This actually
You probably should like go to the website for this and then share the
Yeah.
picture.
Yeah, let me go there.
So this is the M5 Atom or Atom Lite.
Yeah. You guys.
Which one is this? Is this the
Atom.
M5 Atom or the Atom Lite?
Yeah. The Atom Matrix.
The 25 LED thing.
Yeah. So let me share my
screen right now.
Yep, I'm sharing my tab. Blah blah blah. So if you're just hobbyist, you can start with that. But we should go into something more advanced a bit later. So these guys, this is the M5 Atom, and they do link to this. Okay. So this is actually one of those, and you realize that one of the things they do have nowadays is, you see, don't show it. They actually have a groove connector, so it actually makes things easier to interface with your hardware project. So yeah, you have to actually look at what do they support, and my browser just crashed. Damn it. So yeah.
One good thing I would say nowadays is that usually if you buy these boards, the ability to program it is quite simple. You just connect via USB or something, and you are up and running. Rather than in the old days, last time every single board you had to get its own programmer, a separate device.
Not just that, you need to bake it for 15 minutes under UV to erase the EEPROM, right?
Yes.
You have to actually wait, and then you can program it again.
Yes. So, oh man, I actually had a programmer with me, believe it. And now so actually I'm here mostly to show off what I have. So for example, I even have this. So this is the OpenMV Cam. It can run a very small neural network with camera. This is actually very rare because this is expensive. This is almost like 500 ringgit because of the camera on it. And you can actually run neural networks. So now these things are very easy. So Tristan, I use the NRF, that's the favorite. Okay, Sean, what's your favorite one that is? I know you work a lot more, both in school and work. And can you talk about yours if you want to?
Well, I have used a few weirder, like I said, boards before, like the Intel Galileo, for example, which was Intel Atom-based system, lots of RAM. I think it had like 500 megabytes of RAM or something like that, and it was pretending to be an Arduino. So it was. So and the thing that I found very weird about it was that it wasn't deterministic. You could write the same program, upload it, and get different outcomes every single time you upload it.
Are you sure it's the secretly a quantum computer?
Some randomness is in there. Even a simple program like blinking LED, so sometimes it can be sometimes work and then doesn't work. Never mind, try upload again. Oh, okay, it works again.
I think this is secretly a quantum computer.
That was the x86 one, right? The Intel x86 that pretends to be Arduino.
Yes, this is a Galileo board. This I say was very, very badly designed board.
So they were trying to get into the embedded one because they lost the race actually. Like ARM won, right now it's winning, and then you have your RISC people trying to take the cake from them. But Intel basically lost the embedded portion. They were very strong with the desktop, and they thought, oh, mobile phones are not going to be big. People are still going to use like computers, like desktop computers for all their work, and then now everything is doing ARM.
Correct. Yeah. So my turn to talk about the interesting one. So I actually had a lot. So let's go back to what I like. I like the Pico. This is the Raspberry Pico.
It's the new one.
Yeah, the new one. I like this because when it come out, it already has support for MicroPython. And unfortunately, this is actually a bit more traditional as a dev board in a way that it doesn't come with all the Bluetooth and Wi-Fi. So you only have pure the microcontroller part, and you also have the storage and all that. It's very powerful actually. It's very powerful. You can run some deep learning on it. You can run some TensorFlow on it. Somebody actually have port to it. Not too bad. It's interesting. I was supposed to put some sensor on this. The ecosystem around this is still very new. So, for example, all the major manufacturer. So, for example, Citron considered as one now. They actually start making the daughter board. We used to call it daughter board. I call it the extension board for the Pico. So, I hope they will actually. Do you guys have a link to it? Is this one?
I just shared a link to an interesting thing that I recently read about because the Pico has a very cool I/O interface, the programmable I/O. You can do all sorts of weird shit with it. And one of these projects was like bit banging DVI signals, so you can get like 1080p on HDMI through a little microcontroller. Quite cool,
Yeah. Because each of the connection here actually had their own small processor. That's a programmable I/O. It's very powerful. So I didn't play with it yet. I want to play with it. I don't have.
But I wouldn't say it's very powerful. It's very dumb. That's why it's very fast. Because all it does is like on and off, like very fast. Like it has very few instructions on it. So it's almost like a RISC thing. Like very few instructions, but it's very well optimized for those instructions. And so that's why it becomes powerful, because now it's almost like an FPGA in a sense that you tell it how often to do things, and then the whole design is basically done by the programmer. It's not baked into the actual microcontroller.
Yeah.
I've actually worked on a programmable I/O project before last time in my company. We actually supervised a FYP project with a student, and the idea was to make a programmable I/O. And the idea behind it was to the implementation that he did for his project was actually to implement USB. So it was purely software-based USB, and the I/O was doing the bit banging on and off. But it was a very simplified stack-based processor system with very few instructions, just enough to make sure it can do those bit banging stuff, which is quite fun, I thought.
Well, in the end, those USB controllers are programmed like it's not necessarily just like solid state or like transistors, etc. Right? You actually have a protocol. You have a small microcontroller that actually dictates like what the hell is happening. And so
but usually it's a mixture, as in the hardware handles the signaling, and then the software handles the stack. But then in a programmable I/O, the software handles everything, the stack as well as signaling. So it's cool.
Is this like what they call the PHY, the PHY interface? No,
PHYs are the job is signal conditioning. So that's a separate issue. That you can't actually work around that with software at the moment, but maybe in the future you can. I don't know. But for now, you still need a physical signal conditioning on the wire. That's an electrical issue, not a software issue.
Yeah.
I'm going to share one last thing about the interesting thing where you should actually look at the Pico. So I'm going to add one more thing here. So this is actually not what I mean. So this actually very new. You get more support coming soon. So you got all the supporting board for you to prototype. But making it a hardware project that you can package is another story. So the Raspberry Pi Foundation do have it. They do have one of those. So, but integrating the hardware is another thing, as we talked about the previous episode. But you want to prototype, you already have more support coming in very soon. So that's the first interesting one I like to talk about. The next interesting one is, of course, the Raspberry Pi Zero. Not as close, but this is actually something you can hide around. This one I already plugged in with. Let me stop my screen. This one I plugged in with the Raspberry.
Let's make you larger. Then that way, yeah.
Yes. So this is actually the maker head. So for the Raspberry Pi. So this one you actually have all the things to help you to actually debug your hardware hacking and all that. So what else do I have that's interesting?
Yeah, maybe for Sean, like what's the difference for you between a microcontroller and single board computer?
Yeah.
Now that the Pico can also do HDMI 1080p.
Yes.
Well, classic difference is a microcontroller does everything internally, right?
Yeah.
So now we are moving away from single board computers towards single chip computers, where
Yes.
you have one package that can do everything as long as you add on the external like files and analog parts, analog and power.
Yeah. So everything just depends on the pins, right? So even
better integration, so you got cheaper cost, lower power.
Yes. I hope to open up this thing because even the Raspberry Pi nowadays is like a 3-chip thing. It's literally a 3-chip thing. It's like the Wi-Fi and Bluetooth on one side, the CPU on another side. Then that CPU alone would have all the component for hardware I/Os. We just need
GPU and RAM, all on the same CPU chip. Yeah.
So it's a system on a chip. They call it the SoC.
Correct.
I think in the case of Raspberry Pi, it's a SIP. I think.
Yes. Okay. That's another new
inline package.
Okay.
System in a package. I don't know. Anyway.
Yeah, in a package. It's a package.
Yeah. Similar to the Nook stuff, like you actually plug it in, like the new Nook that looks like a graphics card. It's basically a computer package where you just plug into to a host.
Correct.
You have multiple ways to modularize things.
Yes. So yeah. So if you want a Linux computer that's small to do things, you can actually use the Raspberry Pi Zero. I like this for hardware hacking because it's a small size. But if you want to do some software project, I recommend you to get a full-size Pi. Because you need if you want to do the software project, it's better for you to have an Ethernet port. So you want to build a home lab, get a Raspberry Pi instead of doing Wi-Fi. So yes.
But this is more like a small computer, right?
Yeah.
Correct.
I don't see the Raspberry Pi as embedded systems. I always look at it as a replacement for PC.
Yes.
Desktop replacement. And that's how we use it in our office. Our entire office, all the desktops are all Raspberry Pis. So they're not
like
we no longer use PCs. Sorry?
Yes.
Is it a thin client to
we have a central server so most of the hard stuff get done on the server, but the desktop is enough to open your VS Code and
it's like the 90s over again, because in the 90s we had one big computer, which is why Jenkins exists. So Jenkins exists so that you can install something on that big computer where you check out to your source control, then it will pick up at your build computer. That's a build computer which will run the compilers. In most cases, Java, because those days Java is heavy. So you would have a small computer that you usually have is still pretty expensive to a big computer supposed to run the integration. Kids nowadays don't remember this, but it's back to that.
These are it's like a pendulum, so it swings like one way or the other. It's I think it's swinging the other way around because at least Apple is doing a big push of AI, local AI, because of all those privacy, right? Like they want to keep the whole processing local to the device without having a central server doing the thing. And so that might be the thing that pushes over towards the other way around, like where all processing happens again on the local machine, and then the synchronization just happens. Then of course we don't know, maybe the central server does, just because of efficiencies and economies of scale, it's just easier to scale vertical in sometimes where you just have a lot of power just because you can pack things much closer. You get efficiencies of distance because even like a small like a meter will like degrade your electrical uh, the quality of your signals. So
Yes.
yeah, we'll see. Yeah, the pendulum swings,
Because
and it's always interesting to see where things go.
as of right now, uh, as of right now, both the stock of Amazon and Apple are going very strong. So you're going to use stock market as an indicator. It's very hard to see. It's actually very hard to see. And as it turns out, the chat is very, very quiet. Oh well, doesn't matter for now. So yeah. So in one computer project, this one, think about that. So my next
Treat that as a computer lah. It's more powerful than most computers were.
Correct. Unless you want to build a robot, then probably you get a Raspberry Pi, then you build a big robot, then can run all the thing. But if you want to build a robot, you're more likely going to get a
He's gone.
He's frozen. Oh no!
He's dead, Jim. Yeah, and they well some of the things that the Raspberry Pi has been used with, it would be like they got sent into space as satellites, like just because it is like you don't really need high speed stuff happening there. You mostly need processing, like data gathering and then analysis. You don't need like I don't know an Arduino to maybe
Yeah,
the sensors themselves would be the Arduinos, but the processing itself happens on the Pi. Even though
I
the
would
Pi
say
has
the Pi is probably even too powerful for that lah. It
yeah.
probably can be done a lot easier. Yeah.
It's just that it's light enough, I think, for
But
all
the
of
thing-
these like extreme situations.
I think the thing that gives the Pi a huge advantage is the fact that it's very cheap. You can't get that kind of computational power in that kind of price, in that kind of size, the package. There's no other product like it lah. So
Yeah,
so
a lot of
that's the cost lah.
a lot of Chinese manufacturers are trying to like crack this puzzle. Like, why is the Pi so popular? Even though it's manufactured in the UK, it's so cheap, and then so the Chinese people manufacturing will say we can probably do it cheaper, which they probably can, but somehow the ecosystem just gravitated around the Pi. They have their own packages, but it's not as well maintained as the Pi does. So everyone just buys the Pi because it's cheap enough and it's supported well enough that yeah, they do it. And I guess that's the thing that probably uh, got the explosion of all of these microcontrollers, all of these like single board computers is the ecosystem, the open sourcing of the frameworks. Because I remember you were saying like the PICs and all of these older uh, microcontrollers you need to buy, and it's expensive. You need to buy the vendor related things just to program them. And then now we have it was spearheaded by Arduino, and everything just exploded from there. Oh, we have swimming back.
Welcome back.
Aswin,
Hello.
I haven't heard from you for a long time. He says hi, folks.
Oh yeah, Aswin, yes. So the next interesting one that I hope you guys try out is, of course, you can never run away from it. This is the form factor for the ESP32s. This is actually one of
This
the
is
hotter
an
ones.
ESP8266.
Really? Oh yeah, this is
It's
8266. I'm so
C32.
sorry.
Oh, 8266 ah.
No, this is not the 32
8266.
yet.
No. I have the 32 somewhere else.
Yeah,
But
this
this one-
has too few pins. At least like this one has a smaller package.
So
size.
the ESP is very interesting because it got Wi-Fi at least. Now let's get the 32 because that one actually have Wi-Fi 6 and no Bluetooth 5 certified. Is it?
Yes, the Wi-Fi of the ESP32 is still at 2.4 gigahertz. You don't have 5 gigahertz Wi-Fi on the 32.
It's the Bluetooth. The Bluetooth is interesting. And
Then again, it's going to be very difficult for a microcontroller to have 5 gigahertz because
Yes.
that means your clock needs to at least run a bit faster than 5 gigahertz, just so that
Correct.
you can actually like partition signals. I guess you can face lock into 5 gigahertz, but then you lose fidelity, and then you probably like lose packets and those things. So 2.4
I think it's not so much that the analog side, maybe that bears a bit of a factor in terms of the cost, but also in terms of the speed. You for the kind of applications that you're building with, you don't really need the 5 gig bandwidth. Yeah, you only need it because you're using it to turn on lights and turn on fans and stuff like that. Few kilobits per second is enough, man.
Yeah, because think about it, right? All these things are traditionally used for very basic stuff. Your flow, your pipes, your gas pipes. Those things only have 2 value at a time. You're not sending a whole video of your pipes. You're not sending stuff to Mars, right?
It depends. So that's the thing, right? There are a few like ESP32 Cam could use like larger bandwidth. But the thing is, it's the microcontroller itself is the limiting factor because it just couldn't process all of that data, like push things as fast as it can. Like that's why the resolution is.
I once asked the people who made it because I needed an application where we need to push huge amounts of bandwidth across it, and they were like saying that they essentially what they recommended was to compress the data internally in the ESP before actually sending it out. So So in the end, it's still low bandwidth. Yeah, it can do the compression. So just lower the bandwidth requirement.
Correct. So anyway, if you want to interested in the ESP32s for prototyping and all that, I suggest you look at the N5s. I share the link later. So, but it's a bit expensive, but you get the convenience. That's the thing. You get the convenience. So you get the convenience of the connectors and all that. But as I said, expensive. And the cool thing about the ESP that I don't have yet on my screen right now is you can program in the Arduino. You can also program, you want it to be very performant, you can use the official IDE, the official SDK from the ESPs. So you can actually get a lot more on it, but it's also a bit more difficult. But if you want prototyping, you have this, you have Arduino, and you can do MicroPython.
So the only thing I think I have against the ESP32 series and those things is that they have their own
ecosystem.
Ecosystem. It's Extensa, right? It's not ARM. It's not RISC. It's I don't know. Maybe it's RISC, but we have no idea. It's not.
Correct.
At least the Atmel ones, they might be proprietary, but it's well known. Like you can find it in your washing machine, right? So you have support for that. But the ESP32, I don't know how long they will be there. Like what is the code that's running? Nobody's really figured out what the binary blobs are doing on those things. You have an SDK, but you don't know how long it will be supported. So that's the only thing I have against the ESP32 ones.
Because the ESP originally are used for light bulbs. They're really meant for light bulbs, actually. That's the first product. They built a chip to support light bulbs, which is why this guy, the original ESP, is on this form factor, and this is not friendly for prototyping at all. You can't even the layout for the pin is not. You can't even put it on the breadboard. It's not for that. This thing are meant to be put on the light bulb.
Yeah, but this is the development board. This is not by. I don't know if this is an official ESP product, but this is a development board that's supposed to be for a module. Like they are supposed to be a co-processor for that gives Wi-Fi to something like an Arduino or something.
Yes, correct.
It was only recently that someone figured out that the ESP8266 is actually powerful enough and actually did the Arduino support for the editor that everyone realized, oh yeah, I don't need an Atmega 326P or whatever. Yeah. I just used the chip itself to do the GPIO stuff, and then that's where all of the boards came out.
Correct.
Originally, it was really a coprocessor, and it's not even running on the light bulb itself. You have a microcontroller that controls the light bulb, and then you have the Wi-Fi, and then you have your serial protocol that communicates with that. So the ESP8266 is not the one that's controlling the light bulb. It's just figuring out the Wi-Fi.
Correct. So
the ESP8266 brought Wi-Fi to the low-cost microcontroller world. Just before that, every other solution was expensive.
Yes. So it used to be a Wi-Fi board alone is 400 ringgit. That's the hobbyist thing. I'm not talking about the professional grade one.
Yeah. Correct.
Then only after that, when they evolve, then they put they figure out they can put a camera on it. Those are extra things, but still it's very hackable. It's extremely hackable, and you got some good support on it. So I recommend you want to play with this. So this is my next one that's interesting to hack on. Then I already covered Arduino. What else did I give me some name me something that I should show?
Well, whatever you have there.
Yeah.
Whatever.
Okay, then this one. Oh yeah, I should show this later.
Cute.
I got show that later. So this is actually the Arduino. This less of a hardware platform because you don't get the GPIO, but you use Arduino as the IDE to write a game system. I wonder if they still have battery. Nope, the battery died.
You don't have a
this
GPIO, but you have a lot of buttons.
Yeah,
and
correct.
An LCD, right? So that's
Yeah.
if your thing needs buttons and LCD, and I think you should be having like extra pads inside. If you open it up, there will be
They do.
pads, and
So
like just communicate outside to control something.
Because one of these pads inside is used to actually extend the hardware. So that's an official product, but you have to hack it later. But this is actually very cute in a way that because the Arduino have access to the button and sound, it's very capable. So they use it to actually make games. So I like this because it's a cute thing. I tried to write some game on it.
This is the Arduino. Aswin is asking, what is that? The Arduino.
Arduino.
So still being manufactured, still expensive.
Yes, but it's fun. But the only catch is this thing is a hobbyist product. I say call it a hobbyist product because professional game development, you get all sort of support. So your SDK would actually automatically help you do the graphics and all that. You do not get this kind of support on this thing. But it's fun. It's fun to play. It's really fun to play.
Treat it as a machine with an I/O. You got display and you got input ready. You can do all kinds of stuff with it. Like a terminal to access something.
I have a question for Aswin. Like, when is Microsoft going to do their single board computer? Or, I don't know, microcontroller by Microsoft. Well, there's the Azure Sphere.
Yeah, they already have. Yeah, they have.
Well, the thing is, I don't know if they're even if it's getting traction. Like, they sent out lots of free Azure Spheres. I still don't know who's using an Azure Sphere in production.
Correct.
So it's very Microsoft technology centric. So that's the thing.
And again, the question is the ecosystem and the support.
Yeah.
Okay, I have it. So the last one I'm going to talk about, and this is actually one of the features of development board. Not this particular one. This is the OpenMV Cam. You can zoom on it. This one by default using MicroPython and MicroPython. So it's an STM board, very powerful. By default, they can do some basic. Okay, I'm going to share something here. So this is a OpenMV Cam. It have GPIO like the Arduino, and it's also it's powerful enough to do some basic image processing. So, for example, you have the library to read barcode on it and QR code. You can do your filters, some basic filters, inversing camera, so they have that, and it's powerful enough to run a TensorFlow-like. The only catch is you cannot run very deep network. You can recognize face, but my cake detector probably won't work here. It probably won't work here. But this thing, this here would actually represent one of the more feature of the development, hardware development, because even OpenCV is actually supporting a camera board. So the reason is there's this trend of what's the name? Edge computing. So, and one of the things they like to do is to put camera on it and run the neural networks on this thing. So this is actually one example of it, and a lot of those are using MicroPython. So another example for this is actually K210. I didn't buy it yet. That thing also can run MicroPython, and somebody actually implemented There's a new version called MAIX2. That one runs Linux, so they can run neural networks on it like a Linux computer. So this actually I want to show this because this is actually very interesting as a trend. As people putting more and more smarts in microcontroller. I don't even know what is a difference between microcontroller and computer anymore, seriously, because it's very powerful nowadays. Serious. But this is all the thing that I can show off. But you want to know what you should do, which one should choose, drop us a message at Engineers Mind. I have a lot of these toys, so I can give my opinion. But
I
this
thought
is
you were
all.
hoping you can give them away.
No,
Not for free. Opinion for free. You can give opinion for free, but not the boards.
correct. Toys fine.
Yeah.
Toys
Because you said you have a lot of them, so you said you can give them.
A lot
an
of these
opinion.
are close to be a dead technology. So OpenMV Cam are soon to be a dead technology unless they actually step up, because this thing is expensive, and at the same price you get more capabilities now. As
It's
you
that
can
just
write,
like buying a GPU, right? Like 10 years ago, your GPU is like as
Yeah.
expensive as they are now, but the GPUs now are 10 times more powerful than ones 10 years ago. So it's the same thing.
But
It's just
The,
much technology.
the trouble with a lot of all these embedded systems boards is that their lifespan is not very long.
no, it's
The
not very
company
long.
may release one product and then after that the company dies. Yeah.
Correct.
Because the product doesn't sell well enough or doesn't become de facto standard or something like that. So yeah. So it's always often safer to stick to what is well established and known.
Mm-hmm.
So
Apparently, Starbucks uses Azure Sphere. I didn't know. Well, not so he has an extra thing. Not sure if Malaysia Starbucks does. So
I doubt
that's
it.
actually well, yeah, it's an interesting microcontroller. Again, same thing going on. What Sean was saying is the trust in the ecosystem. It most likely the Starbucks is using it because Microsoft is supporting them, and
Yeah.
it's not
Microsoft will
like
get all the enterprise customers lah, the big guys.
Yeah, correct.
The hobbyists susah a bit lah, difficult.
Yeah, correct.
although in their value proposition is good. It's like the there's like you have an encrypted, like it's just like the T2 chip in the Apple computers. You have an encrypted bastion there, and then it's you have like a security
The-
thing. So even if you
The
steal,
trust zone.
yeah,
The trust
If you-
zone is available on most ARM microcontrollers of that class, so it's not special to the Azure Sphere.
I don't know. But they say that if you are able to steal the board or like the chip or something, then you cannot actually like just lift the program from it by like I don't know, by x-raying it or something, or I don't like figuring out through debug ports what the computer what is inside because of the way they design it. But I don't know.
Correct.
It's an interesting thing because that's the biggest problem in IoT, right?
But it's not unique. But the solution isn't unique to Microsoft Azure Sphere. That's what I'm trying to say. It's trustworthy technology that exists on pretty much any ARM controller of that class. So you don't have to use the Azure Sphere. You can use any other controller, any other product.
But some of these things begin to have very, very good support now. Last one I want to show. I hope I can. Okay, I found it. Now I need to open. the. Oh man, these guys are okay. Here you are.
Oh, one thing I think we should not forget to mention is that if you're planning to work on embedded systems and you want to write software for it, it's not just using the Arduino IDE lah. The other very common option is to use an RTOS, a real-time operating system, which is an OS. It is an OS. It's a real OS. But it's low level enough and simple enough that you can use it easily, writing it in C. And the most popular one in the world is FreeRTOS, and it so happens to be owned by Amazon. So it's stable in the sense like it's not going to die tomorrow.
Yes.
But the good thing about like programming against an RTOS is that because of the hardware abstraction layer, As long,
Yeah.
of course, if your board has a hardware abstraction layer, right? Then that means your code or whatever software you write on one board is usually easily portable to a different one. Because if you, for example, you write low-level Atmel or microchip code, it's very difficult to move that to an ARM, like NRF52, for example, directly, and then
Correct.
like NRF SDK going into the STM32 SDK, even though they're both ARM, that if you do low level, it's going to be a problem. But if you're doing something like FreeRTOS or Zephyr or
Yes.
like all of these generic frameworks, and if your if your chip or your controller is supported by the hardware abstraction layer, then that means it's less efficient, I guess, like because of the translation. But then you have portability, and so even though, let's say, the manufacturer, and I guess you saw that that article, right? Like there's this ship in the Antarctic where there's a particular diode that nobody's manufacturing anymore, and so it's like it's like difficult to source that.
But,
so in case your microchip does not is not produced anymore, then at least whatever software that you're using or you program for it is portable to a different one.
Correct. So if you let
what Tristan said is correct, except the problem is that for a lot of these systems using an RTOS, the hardware abstraction layer is not available. Because the hardware is usually very specific when you're dealing with embedded systems. It's not so generic.
It's still hard.
Yeah, it's still you might need to write your own hardware abstraction layer.
Yeah, but it's easier.
Easier, yes, but it still has to
Well, all you need to do is blink some LEDs, right?
So either way, and there's a lot more opportunities to you guys now. So for example, even AWS is supporting some of this hardware. So I'm going to open the link. So you get this actually officially supported by AWS. So for example, so you got more opportunity to hack on things now. So you can use button. So IoT get easier. Even though I hate the word, I extremely hate the word. Let me show you the device because apparently that opens a new link. So this is actually one of the officially supported one. So yeah, you get more opportunity to hack now, but you can start hacking. But professional work, you need to get starting a bit so that you can get an engineer to help. So this is how you get started.
But
so for now,
these are really useful for like farms, let's say. Like you just have a whole like fleet of them, and then it's like figuring out whether it's the moisture level for this particular section is okay, and so it reports to you something like this. So I think this is what Amazon is trying to target. Like they have an educational kit just for people to understand this is possible. So it's like the possibility is there, and then okay, now I need to actually have this working properly. I'm not going to use the same kit because that's just like opens me up for possibilities, but I'm going to do something more professional.
Yes.
What they hope for at the end of the day is that you will feed all your data, all the telemetry data back into the cloud, and you will use their cloud in order to process the data and make some sense from the data, right? Yeah.
Yes.
Same with the Microsoft Azure sphere as well. That's what it's for.
Correct. Yeah. So that they can process. So you have a cow, you got a cow farm, you can use it to measure the cow. So yes. So
methane levels, let's say, so that
yes,
it's for danger, like you don't spark a fire because the methane levels are too high, and then
so
ventilate the whole thing.
So that's the point of the whole series. Actually, I would hope that you guys get an idea that how to do this because there is more opportunities to hack now. And if you can talk to engineers or you are actual engineers that want to go back from software to hardware, so I just want to say the opportunity is there. Things only get more interesting, and I hope the series will help you guys get started. I hope. So yeah, anything you guys want to add just before we end?
No.
If you have questions, you can always message me on Twitter.
Yeah.
That's my handle on the screen. Yeah.
Yes. let me set it up. Oh, can I put it?
When are we expecting your book to be published?
Yes.
Where can we buy it?
I just had to pause writing it for 2.5 weeks because I had to work on some other projects. Yeah,
Yeah.
but, so I'm hoping to get back to it maybe next week. Yeah, but it's five out of the 10 chapters are like there's shit.
Why don't you do something like a drip publishing, like one chapter per whenever it's done?
Unfortunately, I signed a contract with a publisher, so I actually have to deliver. I actually have to deliver it. There is a deadline.
Yeah,
there is a deadline.
Okay.
Let me share. Yep. So you can find Sean here. Can I zoom bigger? Does it make sense to zoom bigger? Yes. So there's the handle. So yeah, talk to us and all that. Next week I have no idea again. After a whole week of plan, I have no idea what we're going to have something again. We may interview someone again. But for before I interview someone, I need to figure out why our notification doesn't work. So I need to find out why. Because for the first 30 minutes, literally no one is here. But let's see, I will read the comment. Don't worry about that. So if you guys happen to stumble upon this channel, subscribe, like, then you'll possibly find and leave some comment. I will read the comment and answer your question. So if that's it, shall we leave early then?
Yep.
Cool.
Bye. See you again.
Bye. Yes.
Night.
Night.